Here's section 10.8, Powers theorems. So the one objective for today is being able to apply the power theorems. So what these are, here's our first one. It is the chord-chord power theorem. What this states is that if two chords of a circle intersect inside the circle, then the product of the measures of the segments of one chord is equal to the product of the measures of the other chord. So that was a mouthful. So this is what it actually means, is that I have these two chords, AB and DC. If I take the length of AE and I multiply it by the length of EB, that is equal to the length of DE times the length of CE, which I have the formula right here. So you're going to multiply the parts. So the multiplication of the parts here is equal to the multiplication of the parts on the other chord. So let's see an example of this. So here we are given the chord, so we have two chords inside the circle, and I want to find x. So let's start with this first chord. Doesn't matter which one you start with, I just chose this one. My two parts are 14 and 7. So I have 14 and x, sorry. I have 14 times x is equal to the other two parts, which is 12 times 7. So to solve this, I get 14x equals 7 times 12, which is 84. So divide both sides by 14. And I get x equals 6. So all I did was I multiplied the two numbers on one chord and equal them to the multiplication of the two other numbers. So let's try it again. In this case, I have two chords where one is 12 and 15, the other one's 18 and x. So 18 times x, because this is one part of the chord. And then I have another part of the chord. And that is going to be equal to 12 times 15. And that's because 12 is this part of the chord, and 15 is that part of the chord. So again, just multiply the parts. So 18 times x just becomes 18x. 12 times 15 becomes 180. So divide both sides by 18, and you get x is equal to 10. The chord is actually one of the easier ones because you just multiply the parts. There's really nothing to figure out. Just multiply and divide. Now the second one is the tangent secant power theorem. Again, big mouthful, but don't worry, I will explain it afterwards. It is saying if a tangent segment and a secant segment are drawn from an external point to a circle, then the square of the measure of the tangent segment is equal to the product of the measures of the entire secant segment and its external part. What that actually just said, because that was a mouthful, was that AB squared. So this is my tangent line right here. If I take this length and square it, it is equal to the length of the whole 80, so the length of the whole secant segment, times the length of AC, which is just this part. So here's not the parts, it's the outside part equal to the whole, or times the whole. So it's the tangent segment squared, because there's only the one piece, so we square it, equal to the outside piece times the whole length of the secant segment. And again, you could have flipped these AC and AD, doesn't matter, because when you're multiplying, order does not matter. So let's see this in practice. I want to find x here. So we got to locate the tangent segment first. The tangent segment is a line that's outside the circle that only touches the circle once, which would be this line right here, 24. So here is my tangent. So I do 24 squared. Let me redo that. That 24 looks awful. So 24 squared equals, I need the whole length here this time. So the whole length. And because we don't know what it is, I have to add them together. So x plus 18 times just the outside. So just the outside piece of that, which is 18. So to solve this, what I'm going to do is I'm going to do 24 squared, which is 576, equals, I'm not going to distribute the 18 through, and I'll show you here why in a second. And I'm going to leave that as x plus 18 times 18. Now if I have this, I can go straight to dividing by 18. So I can divide both sides by 18, and I get 32 is equal to x plus 18, because those 18s cancel out. So then my last step is just to subtract 18 from both sides. So I get x is equal to 14. Now if you would have wanted to, you could have distributed this through and you would have had 576 is equal to 18x plus 324 subtract 324 from both sides, and you get 252 is equal to 18x, and hopefully we did everything right. If we divide by 18, we should get 14, and we do. So x equals 14. So it doesn't matter which way you do it. I like doing it this way because I save myself a step. You could do it this way. It's completely up to you. You'll get the same answer no matter which way you do it. So let's try it again. Now I have this example. So again, first find your tangent segment. So that is the segment that's all by itself. If it helps, remember it's a number that's all by itself, because 8 and x, they share a line. We can't use that. So we start with 12. So we get 12 squared equals, now I need the whole length. So the whole length here. We don't know what that is, so we have to add it. So x plus 8 times just this outside piece right here. Oops, and I just covered up our number, but that is 8. So when we go through this, we get 144 equals, if you want to distribute it, you can get x squared, or 8x, sorry, plus 64. Then our next step would be to subtract 64 from both sides. And we get 80 is equal to 8x. So divide by 8, and we get x equals 10. So just to show you that it gets the same answer no matter which way you do it, if I had done it the other way, which is the way I did it first, without distributing, I would have gotten 144 is equal to x plus 8 times 8. Divide both sides by 8. And I get 18 equals x plus 8. And as you can see, when you subtract 8 from both sides, you also get that x is 10. So again, distribute, not distribute, doesn't matter. Be comfortable with it though, because there will be times when x is on the outside and you will have to distribute that. So our next example, or next theorem, is the secant power theorem. Again, a lot of words. I'll explain it when I'm done. So if two secant segments are drawn from an external point to a circle, then the product of the measures of one secant segment and its external part is equal to the product of the measures of the other secant segment and its external part. So what that actually said was the length of AC times the length of BC, so times this length right here, is equal to the length of EC times the length of DC. So that's the whole length times the outside is equal to the whole length times the outside. So whenever you're dealing with secants, you'll always work with the whole length and the outside piece. You'll never work with the inside number. So let's see how this works. Here I give this example. I want to find x still. So the whole length right here of this first segment is x plus 7. Then we need to work with just the outside piece. So that is 7. So I'm going to multiply these two things. Equals the whole length here. So I'm going to add these two numbers up. I'm going to go ahead and do it over here. So 13 plus 8 is 21. So this is 21 times just this piece right here, which is 8. So since I don't have an x out here, I'm going to leave this as is. I really don't want to distribute. It's extra work. So I have x plus 7 times 7. Is equal to 168. So divide both sides by 7. And I get x plus 7 is equal to 24. So subtract 7 from both sides is the last step, and we get x equals 17. Which kind of makes sense because 13 is bigger than 8, so I would suggest, or I would think that the segment inside the circle would also be bigger than 7 for the other side. So let's do one more example just like this. So again, we're going to find x here. So we need to start with the whole segment. So the whole length right here. We don't know it, so we have to add them. So the whole length is 6 plus x. I'm going to times this by just the outside piece, which is 6. And that is equal to the whole length over here. And that whole length is, let's see, 7 plus 11 is 18. So this is 18 times just the outside piece again, which is 7. So I don't want to distribute because I'm going to save myself some work and there's only one x. So I leave this as 6 plus x times 6 is equal to 126. Divide both sides by 6. I get 6x, or 6 plus x, excuse me, is equal to 21. Last step, subtract 6 from both sides, and I get x is equal to 15. On both of these problems, this is when we only have one x to play with, when x is in a very special spot. But we have two other examples where x is in a very different spot, and it's going to give us a little bit trickier of an answer. So with this example, we still want to find x. This is a tangent secant, so we're going to use a tangent secant power theorem, which says the tangent, which in this case is x, so the tangent squared, so I do x squared, is equal to the whole length. So the whole length here is 9 plus 16, which is 25. So 25 times just this outside piece, which is 9. So if I fill this in, or let's keep going. So we get x squared equals 25 times 9 is 225. Then to undo this square, I'm going to take the square root of both sides. And we get a nice number because 225 is a perfect square. So we get x is equal to 15. And we are done. So in this case, x is what gets squared, so we have to square root it at the end. Before, we were given x somewhere in here, and we had to divide and then subtract everything. So this a little bit less work, but it's a little bit trickier because of the square. And one more example, very similar to it, we now have the secant secant, which is where we take the whole length here and the whole length here, because we can't combine a number and a variable, is x plus 11. So we do x plus 11 times just the outside piece, which in this case is just x. So if you see here, before we had a number here, we can't divide by x. So this would be a good time where we're actually going to have to distribute. So this is going to be equal to the whole length here, which in this case is 6 plus 15, which is 21. So this is equal to 21 times just the outside piece, you guessed it. So just 6. So I'm going to just take this x and distribute it inside the parentheses. So x times x gives me x squared, plus x times 11 gives me 11x, equals 21 times 6 is 126. Now, since I have two x's, we have to go back all the way to chapter 9. Not a very long journey. And we have to use a quadratic formula, which I'm going to write up here, was negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Before we can use that, we have to have this so this is 0 at on one end. So I'm going to subtract 126 from both sides. And I get x squared plus 11x minus 126 is equal to 0. So this is a bunch of gibberish if you don't know what A, B, and C stand for. So this number right here in front of x, which is very invisible, called a 1, that is our A. The number in front of just plain old x is B. And the number that is all by itself, including the sign, don't forget the sign, is my C. So I'm going to plug it all into here. So I get negative B. Well, B is positive 11, so negative of 11 is just negative 11. Plus or minus the square root of 11 squared minus 4 times A, which in our case is 1, times by C, which in this case is negative 126. And this gets divided by 2 times A, which is 1. So if I do this, I get a negative 11 plus or minus. If you do this all in the calculator, so type in 11 squared minus 4 times 1 times negative 126, take the square root of it, you end up getting 25. So if you need to, pause the video, check, do this in the calculator, make sure you get the same answer. And we divide that by 2. So when we get that, we now have to write two different equations because we have a plus and a minus here. So I'm going to do negative 11 plus 25 divided by 2. And I'm going to do negative 11 minus 25 divided by 2. So all I did was I split this plus or minus into two different equations. So in the first one, negative 11 plus 25 is 14. And I divide that by 2, I get 7. In this case, if I do negative 11 minus 25, I get negative 36 divided by 2, which is negative 18. So now you're thinking, well, I have two answers. How can it possibly be two answers? It can't. Because what's wrong with this answer? Why can I not have a negative number for a length? Because we never have a negative distance. So if you're stuck with a positive and a negative answer for any of these problems, automatically it is positive. Length can never be negative. Now, forewarning, there is a problem on your homework tonight where you will have two positive numbers. Don't worry, they actually are both correct. It's just the way the problem was set up. So to review everything, we were given three power theorems. We were given the chord core, which looks like this. It was just two chords inside of a circle. Tangent secant, which was a tangent line and a secant line. And a secant secant, which was two secant lines. So to review what the formulas were. For a chord, that was one part of the chord times its other part is equal to one part of the second chord times its other part. So I kind of have the color coding going. So I got red times blue is equal to purple times green. On the tangent secant, it is the tangent line squared, so the red line squared, equal to the whole line, so JM, times the outside piece, JL. So JM is the dark blue, so that's the whole line times the light blue. And then secant is the little tiny piece out here of one secant line, so AB, times the whole length of AC, equal to AD, again, tiny piece outside, times the whole length of AE. So what I want you to do now, to make sure you understand what this is doing, so if you don't understand it, you can ask me for questions. I need you to answer two questions for me. These are the ones that go on the quiz. So I need these two answers for example 9 and example 10 on your quiz that you're going to do after you take this. So I hope you're writing it down. If you don't have access to the quiz, always take it in class or in the library. Either one's fine. So here's example 9. This is the chord, and I want you to find x for me. So go ahead and pause it, solve the answer. Then when you're done, come back and look at example 10. And here's example 10. Here we're given the tangent secant power theorem. So I need you to solve that one. Again, both 9 and 10 go on the quiz. Make sure that you're putting an answer in for every question, even if it's I have no questions to put on there, that's fine. Make sure if you have a question, please ask it. I will do my best to answer you before class starts. That way you can get an answer for it.